So the final video for Unit 8, Practice 3 mole conversion packet is where I take both sides of the mole flowchart and I combine them into one big problem. So remember, we've already done problems where we went from particles to moles or moles to particles, and we did problems in Part B where we went from mass to moles and moles to mass. So now we are going to do problems where you start on the mass side, go mass to moles, and then go mole to particles. Or you start on the particle side and you go particles to moles and then moles to mass. So these are a little bit longer problems, but we're just stitching together the two skills that we've already worked on. So if we're going to take a look at this first problem as an example, it says that we are asked to find the mass of F2, so that's this part right here, when we are given 2.0 times 10 to the 23 molecules of F2. So that's this part right here. So we are starting this time with molecules. So we're starting over here with particles, and we are ending with mass. And there's no direct link from particles to mass. So we have to go particles to moles and then moles to mass. And when I do that, I identify my relationships, right? So I see that when I go from particles to moles, I need to have the 6.02 times 10 to the 23rd, which is what I have right here. So this is my particles. My particle to mole relationship says 6.02 times 10 to the 23rd molecules of F2 is going to be equal to 1 mole of F2. Okay, so that's the first relationship that we're going to need to use. When we look back, so I'm going to just go, when we look back at the mole flow chart, so now I've gone from particles to moles. Now I need to go from moles to mass. And when I go from moles to mass, I need to know or calculate the molar mass. And this time it has to go on top. So my molar mass in this problem, or this molecule of F2, because there was a 2 behind the F, that told me that there were 2 F's. So I multiplied F, so I took 2 F's times the mass of fluorine, which is 19, and I got 38 grams in 1 mole of fluorine. So my molar mass here is 38 grams in 1 mole. When I set this problem up, I really depended on the mole flow chart. I started with particles and I went to moles. When I followed the arrow from right to left, 1 mole had to be on the top and the 6.02 times 10 to the 23rd molecules had to be on the bottom, which is what I'm representing here. So I have 1 mole of F2 on top and 6.02 times 10 to the 23rd molecules of F2 on the bottom. And then the next part of the mole flow chart is going from moles to mass. And when I go from moles to mass, my calculated molar mass goes on top and 1 mole has to go on the bottom. So in this case, that's what I did. I put the molar mass of fluorine on the top and the 1 mole on the bottom. And the other thing that I'm going to try to point out here is that if you see molecules on top and molecules on bottom and moles on top and moles on bottom, those units cancel out, and that allows me to calculate my mass or grams. The other thing I want to make the point of is that we're going to multiply straight across the top and straight across the bottom. So to kind of like put that together, that would look like this: 2.00 times 10 to the 23rd times 1 times 38.00 grams. And all of that's going to be over the 6.02 times 10 to the 23rd. And so when I go to plug this into my calculator, I'm going to multiply across. So 2.00 second comma, and then I'm going to type 23. So that should look something like this: 2.00 E23. And I'm going to multiply that by 38.00, which should look something like this. And then I'm going to hit enter. So when I hit enter, I get 7.6 E24. At that point, I'm going to hit divided by, and then I'm going to type in 6.02 second comma 23, which looks like this. So I have the answer, divided by 6.02 times 10 to the 23rd, and I'm going to hit enter, and that's going to give me a value that looks something like this. So my final answer here is going to be 12.624587176 . I'm going to only tell you to go to 2 decimal places, so I'm going to rewrite this to be 12.62, and that's going to be grams of F2. No, not Fe, F2. So that's going to be your final answer for this problem, like that. So that's one example. And then the second example that I want to do is going to have you do a little bit more math, but we're going to do it quickly together, and hopefully we'll feel pretty good about this process. In this problem, you were given 1.76 grams of CuNO32, which is called copper nitrate, and you're asked to calculate number of molecules of CuNO32, which is particles here.
Christopher Miller, please report to the school office.
So I'm going to start by looking at my mole flow chart, and I'm going to start with grams and go to moles and moles to particles. So it's going to be a two-step problem again. So when I go from mass to moles, I need to calculate the molar mass. And at this point, I need to do that first before I do anything else. So I'm going to take a look at what I've been given here. So in this problem, it looks like I have Cu, or copper, and there's one of them. So I'm going to take 1 Cu times the mass of copper, which is 63.55. Those are ugly. Let's try that again. Cu times 63.55 grams over 1 mole. And we're going to multiply that right out right away, which is going to be 63.55 grams in 1 mole of copper. Now I need to look at nitrogen. Nitrogen is here. There's a 1. There's nothing behind the nitrogen, so we assume there's a 1, but there's a 2 outside the parentheses, so I'm going to multiply that, which means that I'm going to have 2. So 2 times 1 is going to be 2 nitrogens times the mass of nitrogen, which is 14.01 on the periodic table. And when I multiply that out, I get 28.02 grams in 1 mole of nitrogen.
Antonia McFarlane, please
And then
return to room 128.
I have a 3 behind the oxygen here and a 2 outside. So I'm going to multiply the 3 times the 2, which is going to give me my 6 oxygens, times the mass of oxygen, which is 16.00, and that's grams in 1 mole. So I'm going to multiply that out. So I'm going to take 6 times 16, which is 96 grams in 1 mole of oxygen. And then the last part of this is I have to add that all together. So I'm going to add that all together. So it's 96 plus 28.02 plus 63.55 gives me a molar mass of 187.57 grams in 1 mole. Now, let's go back and look at the mole flow chart. The mole flow chart says that when we go from mass to mole, the molar mass has to be on the bottom. So I'm going to do that. I'm going to transcribe that value right here. So I'm going to put the 187.57 grams of CuNO3 on the bottom. And then the mole flow chart also tells me that at that point, if molar mass is on the bottom, 1 mole has to be on top. So I'm going to put 1 mole on the top. CuNO3 2. And so now at this point, I've gone from mass to mole. Now I need to go from mole to particle. And when I go from mole to particle, I need to use the relationship of 1 mole is equal to 6.02 times 10 to the 23rd. So that means 1 mole has to be equal to 6.02 times 10 to the 23rd. So if I look back at the mole flow chart, it says the 6.02 times 10 to the 23rd is on top and the 1 mole is on the bottom. So I'm going to start with the 6.02 and put that on top. So 6.02 times 10 to the 23rd, and that's going to be molecules of, in this case, CuNO3 2. And then again, according to the mole flow chart, 1 mole has to go on the bottom. So I'm going to put 1 mole of CuNO3 2 on the bottom. And so now at this point, we're going to multiply straight across the top and straight across the bottom. And so when we do that, that kind of combines out to be 1.76 times 6.02 times 10 to the 23rd over the 187.57. So it looks like we're doing some multiplying across the top and then dividing. But before we do that, I want to touch base with what units have canceled out. So it looks like grams of copper nitrate have canceled out on top and bottom. Moles of copper nitrate have canceled out on top and bottom, and we're left with molecules, which is what we're trying to find. So I'm going to go ahead and put this into my calculator by taking 1.76 times 6.02 second E. So again, that would look something like that. I'm going to add the 23. It would look something like that. And at this point, I'm going to hit enter. When I hit enter, I get like not a weird number, but I get a number that is 1.05 times 10 to the 24. I'm now going to divide that by 187.57, which would look like this if you're putting it in your calculator. And then I'm going to hit enter again. And so when I hit enter again, I'm going to get this bigger, longer number that looks like that. So I'm going to record that down here. And it looks like I'm running out of room here a little bit. So I'm just going to run down here, right down here for a moment. So it's going to be like, oops. So it's going to be 5.64864986E21. So the first thing we're going to do is we're going to round that to have two decimal places. So I'm going to rewrite that to be 5.65. We are then going to take it out of calculator language and put it into human language, which means times 10 to the 21. And that's going to be molecules of CuNO3 2. So this is our final answer. And yes, I spilled over a little bit into the next problem, which you still have to do. But now we have done a problem where we've gone from mass to mole to molecules, and we've done a problem where we've gone molecules to moles to mass. So at this point, we have done every style of problem that you can do using the mole flowchart. And I'm going to post these videos on Google Classroom, and I'm also going to post the worked out examples that we did together so that you can have visuals to look at as well. Good luck, and this worksheet, this packet is due at the beginning of the next block.